Good afternoon, everyone. Thanks for joining the Computer Society of India's webinar focusing on sustainable software architecture. Today, we are privileged to have an expert who will shed light on this important topic. Today, I request Dr. Jayashree Rao, Principal of ISTS for College for Women, to provide an overview of the topic and introduce our esteemed speaker. Ma'am, please.
Thank you, Sahita Garu. Good afternoon, all. I'm thrilled to welcome each and every one of you to this webinar on sustainable software architecture. Today, we have the privilege of hosting a distinguished scientist who will unravel the subject. As we navigate the ever-changing landscape of technology and innovation, the importance of sustainable practices in software development becomes increasingly evident. Today, we have gathered to delve into the realm of sustainable software architecture, a concept that goes beyond mere functionality to embrace longevity, adaptability, and efficiency in software systems. In the digital era, where technology evolves at an unprecedented pace, the concept of sustainability extends beyond environmental concerns to encompass the longevity, adaptability, and efficiency of software systems. Sustainable software architecture emerges as a guiding principle to design, develop, and maintain software solutions that endure the test of time while minimizing adverse impacts on resources and stakeholders. At its core, sustainable software architecture embodies principles that promote modularity, flexibility, performance optimization, resilience, and continuous improvement. By integrating these principles into the design, development, and maintenance of software systems, organizations can achieve a multitude of benefits, including reduced technical debt, enhanced scalability, improved user experience, and minimized environmental impact. Throughout this talk, we will explore the key components of sustainable software architecture and delve into real-world examples and best practices. We will discuss how organizations can leverage sustainable architecture principles to drive innovation, mitigate risks, and achieve strategic objectives in today's dynamic business development. Moreover, we will examine the role of sustainable software architecture in fostering collaboration, knowledge sharing, and ethical practices within the software development community. By embracing sustainability as a guiding principle, we can collectively contribute to building a more resilient, adaptable, and inclusive digital ecosystem for generations to come. Join us on this journey as we unravel the principles, challenges, and opportunities associated with sustainable software architecture and describe how it can pave the way for a more sustainable and prosperous future in the world of technology. So without further ado, let us move into the fascinating universe of sustainable software architecture. Thank you for being part of this learning experience, and I hope you will find today's seminar both enlightening and inspiring. Before passing on to the Madam Manjula Samuel, let me take a couple of minutes and introduce her. Actually, I'm honored to introduce Manjula Samuel, a distinguished leader in the kingdom of technology with over 2 decades of insightful experience. She is serving as a senior director in Capgemini Financial Services Division. Manjula brings a wealth of experience in architecting innovative solutions and driving business transformation initiatives. Throughout her career, Manjula has demonstrated exceptional proficiency in designing and leading expertise projects that span business transformation, application modernization, and cloud migration. Her strategic acumen has empowered business leaders to achieve their objectives of increased growth, enhanced customer retention, and reduced expenses. One of Manjula's notable accomplishments is her instrumental role in designing, architecting, and implementing API service architecture integrating with DevOps practices. This initiative has facilitated seamlessly of enterprises across third-party systems, mobile, enabling organizations to unlock connectivity and moreover, Manjula is entrusted with the responsibility of developing competencies, solutions, abilities that establish a leadership position for Capgemini in the industry landscape. Her visionary leadership and commitment to excellence have consistently driven innovation and value creation for clients and stakeholders alike. Please join us in welcoming Manjula Samuel, a visionary leader at the forefront of technology innovation, as she shares her invaluable insights and experience with us today. We are privileged to have such a star performer as a speaker today. Let us make use of this opportunity. Please do not hesitate to ask any questions. Post them in the chat. Madam, the floor is yours now. Over to
Thank
Madam,
you.
please.
Yeah, thank you. Thank you so much, ma'am. Thank you for inviting for this. Hello, everyone. Welcome to the session on the sustainable software architecture. I'm excited to have you join us today as we explore the intersection of technology and environmental responsibility. So in today's rapidly evolving digital landscape, the demand for innovative software solution is greater than ever before. However, with this increasing demand comes a growing awareness of the environmental impact, of our technology-driven world. So from data centers consuming vast amounts of energy to electronic waste piling up, the need for more sustainable approaches to software development has been more urgent. So sustainable technology is also one of the Gartner's top strategic, technology trends for 2024. So make the most of it. So during this session, we'll delve into the concept of sustainable software architecture and discuss how it offers a pathway towards more environmentally conscious and socially responsible technology solutions. We will explore the principles, the best practices of the sustainable software architecture and examine how they can be applied throughout the software development lifecycle. And but beyond just understanding the theory, we'll also kind of explore some of the actionable insights and examples that demonstrate the practical benefits of this sustainable software architecture. So from reducing the operational cost and improving energy efficiency to enhancing a brand reputation, the sustainable software architecture offers a wide range of opportunities for organizations to look into a more positive impact on the planet while staying competitive in the digital age. So I believe that by coming together to explore these ideas and share our experiences and perspectives, we can inspire a positive change and drive meaningful progress towards a more sustainable future. So let's dive in, learn together, empower ourselves to create software solutions that not only meets the needs of today, but also safeguard the future generations to come. So thank you for joining me on this journey towards the sustainable software architecture. So just moving to the next slide. Kit, you'll have to help me here. Yeah, just the agenda, as I was saying earlier, we'll just discuss what's exactly the definition of it, the principles. How do we integrate it with the traditional software architecture? How do I integrate it into the software development lifecycle? And once we do it, how do we go about measuring and monitoring along with the KPIs? And then some actionable insights. So in conclusion, on discussion forum. So moving to the next slide, please. So sustainable software architecture refers to the design and implementation of your software systems with a focus on a long-term viability, adaptability, and environmental conscious. So it has various factors it considers, be it the scalability, be it the resource efficiency, the energy efficiency, or the maintainability, and ability to evolve over time while minimizing your negative impacts on the environment. So what kind of environment challenges, moving to the next slide, the environment challenges that kind of led to it, right? Being the increase in the energy consumption, the carbon emissions, the electronic waste generation, and the role of system software that is contributing to these challenges through be it the inefficient, the resource usage, or your purely optimized algorithms or not following the right best practices. So the goal and objective of it is to potentially to mitigate the environmental impact while delivering value to the stakeholders. And secondly, align with the broader sustainability initiatives, corporate social responsibility goals, and regulatory requirements. So I want to kind of discuss, what is the foundation or the key principles of the sustainable software architecture includes. So moving on to the next slide. Yeah. So just before that, a very more simpler definition of your sustainable software architecture is about finding the perfect balance between functionality, efficiency, and the environmental impact. The next slide, please. Yeah, the next one. Yeah. So the key principles, something which you all are aware and we're already kind of leveraging it, is the modularity and reusability. You're breaking down your software into a modular components that can be easily reused across different parts of the system or in your future project codes. And this basically reduces your redundancy, your improves your maintainability and minimizes your development time and your resource consumption. The second part is basically the scalability, right? You accommodate your growth and increased demand without sacrificing your performance or requiring any significant changes to the architecture. So you basically can adapt to the changing requirements and usage patterns over time. Third is the energy efficiency. How do you minimize your energy consumption, for example, by reducing unnecessary computations or your using your optimized algorithms, leveraging energy efficient hardware, contributes to the the sustainability by lowering the carbon emissions associated with running the software. Fourth is the resource efficiency, how you efficiently utilize your computing resources, such as be your memory usage, your processing power, or your CPU usage, network bandwidth. Again, it helps in the minimizing the impact of the software systems environmentally. The fifth one is your flexibility and adaptability. Building your software with flexible and adaptable architecture enables it to evolve over time in response to the changing requirements, or be it on the technical advancement. So it could be basically reducing your major redesigns or rewrites. The sixth would be the minimal environmental impact. Considering the impact of the software development practices and technology, be it the
ठीक
choice
है
of programming
मुझे वो
languages
बॉडी शेमिंग जैसा
or
फील हुआ है मजा मजा नहीं लोग मुझे लिख रहे इस तरीके मतलब सच में इतना फिट ये वो 2-3 गेम खेलने के बाद मुझे लगता है ना
sorry, I request to please go on mute. Yes, thank you. Be the choice of the programming languages, frameworks, or the hosting environment helps minimize the the carbon footprint or any kind of negative environmental effect associated with the software development. And lastly is the life cycle considerations, taking into account that the entire life cycle of software from development and deployment to maintenance and eventually the decommissioning ensures that we are applying these principles at every stage, including even the disposable or recycling of your hardware and software components. So overall, the sustainable software architecture aims to create software systems that are not only functional, efficient, and adaptable, but also it's environmentally responsible and considers a long-term impact, on the planet. Now going to the next slide is basically how we're going to integrate it with the traditional architecture concepts with examples, right? So let's explore that. The first one is the modularity and reusability. Your applications are built in a single indivisible unit. So breaking down into more of a reusable modules promotes your modularity and flexibility. So you could be decomposing a monolithic e-commerce application into microservices, allowing each service to be independently developed, deployed, and scaled. So for the sustainability, each microservice can be optimized for resource efficiency, such as minimizing your DB queries, or using your energy efficient algorithms. You also have the layered architecture. That's basically the model view controller pattern, where it separates your application into three layers: the model data layer, the view presentation layer, and the controller, the business logic layer. So each layer can be optimized for energy efficiency and resource usage while maintaining a separation of concern. So the model layer can be optimized by using efficiently database queries or data caching mechanisms to reduce your server load and energy consumption. The view layer can employ a client-side caching and lazy loading techniques to minimize, again, the network request and thereby improving your performance, leading to energy savings. Then you also have your service-oriented. It decomposes your complex systems into loosely coupled services that communicate via standardized interfaces. So you could be having services for an account management or a transaction or notification. So by optimizing each service for energy efficiency, such as, again, minimizing your DB queries or optimizing your network communication, the overall energy consumption of the application can be reduced drastically, right? And additionally, you can also dynamically scale the services based on demand, can further optimize your resource usage and energy efficiency. Then you have your event-driven architecture. It basically decouple your components by allowing them to communicate asynchronously via events, prior event processing mechanism. So in a real-time analytics, say, for example, an analytics system using your event-driven architecture, events are generated from user interactions or system events. So by implementing this kind of event processing mechanism, the system can prioritize the energy efficient event handling, such as you could be having your batching events for processing to reduce your CPU usage and energy consumption. Then you have your scalability and elasticity. I mean, it basically ensures the systems can handle varying workloads and maintain your performance. So this involves kind of dynamically allocating your resources based on workload domain while considering your energy efficient metrics. So in a typical cloud-based application, auto scaling mechanisms are dynamically adjust resources based on traffic patterns. So by configuring your auto scaling policies to consider energy efficient metrics on this, you can scale your resources only when necessary, thereby again minimizing your energy consumption and reduction. So by integrating the sustainability principles with traditional architecture concepts in these examples, software systems can achieve both functional requirements and your environmental sustainability goals. So moving on to the next slide. We have to integrate at the various stages of the software development life cycle to promote environmentally conscious practices, right? So the key areas where within the SDLC, that's nothing but the software development life cycle, where we can apply these principles over here. So coming first to the phase of requirement gathering in the analysis phase is where, during the gathering process, we need to identify the areas where I can reduce my energy efficiency, increase my energy efficiency, or reduce my how I go about reducing my optimization and reducing my the carbon footprint, right? So you conduct some kind of environmental impact assessments. You assess what are the potential environment impact of the software throughout its life cycle. So the sustainability requirements might include, okay, minimizing the server load to reduce your energy consumption. So this requirement could drive decisions such as, okay, I need to use efficient caching mechanisms to reduce my database queries and employ maybe a lazy loading techniques to minimize my resource usage. Or be it, say, coming to the design and architecture, I have designed my softwares with the modular architecture that basically promotes my reuse of patterns using algorithms and data structures, which basically are much more energy efficient, reduces your energy consumption, including my scalability and elasticity as part of my design and architecture. So it could be as, not having multiple API requests and trying to reduce, your major server request, making your API could be segregating our user authentication and authorization to separate microservices and facilitate more efficient resource allocation, reduce the overall impact. Moving to the development and implementation phase, encourage our developers to write clean and efficient code. Moving to the next slide. Um, Developers to write clean and efficient code that minimizes your resource consumption, reduce your energy usage, and promotes the sustainability. You optimize your code and algorithms for performance to minimize, again, your energy consumption as part of it. Use more development tools and frameworks and programming languages that prioritize, again, the energy efficiency and the resource optimization. So we could be writing kind of better efficient, identifying a better efficient algorithm usage, or could be use of caching. Coming to the testing and quality phase, you can performance testing, optimize the resource usage, and ensure that the software meets energy efficiency and sustainability goals. Perform environmental testing to assess the software's impact on the system resources and how much are they consuming, again, the energy. So in a typical, say, a cloud-based streaming service, performance testing might involve simulating high traffic conditions to identify potential performance bottlenecks and optimize your server configurations for energy efficiency to minimize your power consumption. Coming to deployment and operations, optimize the cloud deployments to minimize energy consumption, reduce server idle time, and improve the resource utilization. Implement the monitoring tools to track energy usage, resource consumption in real time, and identify opportunities for optimization. Configure the software and hardware settings to maximize the energy efficiency over here. So, for example, deploying a web application on a cloud platform, say like AWS with auto scaling capabilities, it allows the system to dynamically adjust the resources, based on demand. So this further kind of helps optimize our the resource utilization and energy consumption. The next is maintenance and updates. Implement the software updates and patches that, again, prioritize your energy efficiency and the optimization. Adopt sustainable maintenance practices to ensure the ongoing viability of the software. It could be including your code refactoring, performance tuning, periodic environmental assessments. So this might involve like regularly reviewing and optimizing, say, for example, your database queries to minimize the server load and energy consumption, and ensuring that the software remains, efficient and environment friendly over the time. And lastly is the knowledge and the documentation and knowledge sharing. So all the best practices and whatever the sustainability considerations that we have for the software development teams within the knowledge base can promote the awareness and encourage the adoption of the sustainable software architecture principles across the projects. So this documentation, it could include be it the case studies, be it the guidelines and lessons learned from previous experiences. So by incorporating these steps into our software development process, the architecture kind of meets the current needs and also adapts to the future challenges, all while minimizing its environmental impact and supporting your long-term viability. Now moving to the next one, like how do I go about measuring and monitoring? As of now, most of it we are kind of, some of it we're already implementing it, but it's just that we have to start doing it very consciously, right? And that way is how we kind of put the KPIs around it, and then we kind of start tracking, towards that. So first one is you're defining the sustainability metrics, define what should be the environmental aspects of the software development that are most relevant to us. We want to track be it the energy consumption or your carbon emissions or your resource usage, right? Then you establish your baseline metrics, right? Gather the data on how it is on the current environmental performance, and then we baseline the metrics that serves as a reference point, for measuring the improvement. Then we can also conduct the environmental impact assessments called, life cycle assessments, where we evaluate the impact of the software systems across the entire life cycle from design to development and, the operation, and finally the disposal, right? So there are some software tools and methodologies, such as, your sustainability software engineering framework or your life cycle assessment software to assess these environmental footprint of the software projects. Then you define once the KS monitor, right, you track this performance metrics such as, be it the response time, the throughput, the latency, to assess the impact of this initiatives, on the software and the user experience. Implement the monitoring tools and assessments. You deploy monitoring tools such as, be it the energy meters or the performance monitoring softwares to collect real-time data on the energy consumption and resource usage. And we have to integrate these monitoring systems with the software development and operations process to continuously collect, analyze, and visualize these metrics and performance indicators. So next, after that, once we analyze and collect the data to identify the trends, patterns, and areas for improvement, be it in the energy efficiency or the resource optimization and the environmental impact. And then we interpret these performance metrics to assess the effectiveness of sustainability initiatives and to make data-driven decisions to optimize the software. Reports, summarizing and identifying and communicating to the right stakeholders, and raising awareness and basically fostering a culture of sustainability within the organization. And finally, we have the establish the feedback loops, to continuously monitor, measure, and optimize, incorporating the lessons learned and the best practices, into the future software development projects. Yeah, just moving to the next slide, Kitty. I just covered thing. So here I want to kind of elaborate on the challenges and considerations in the sustainable software architecture, how we involve, given the complexity and the obstacles that is involved in designing and implementing this environmentally conscious software systems, and what are the considerations that can be taken into view. So first one is the complexity of the software systems, where we know that some systems are software are really inherently they are complex, consisting of numerous interconnected components and layers. So you need to balance your functionality, performance, and environmental considerations can be challenging. So simplifying the software architecture and promoting modularity can help manage complexity and facilitate the implementation. You break down the monolithic architecture into smaller and reusable components, and adopting microservices or a SOA based can improve your flexibility and scalability with promoting the resource efficiency. The trade-offs between, that's when is the trade-off, the challenge between choosing between performance and sustainability. Sometimes when you're optimizing for energy efficiency, it may also require sacrificing your performance or your functionality. So balancing the performance requirements with the sustainability goals, it requires a careful consideration and trade-off analysis. So implementing energy efficient algorithms or optimizing your resource usage and leveraging caching and or for example, the comprehension techniques can help minimize the impact on performance while maximizing the sustainability benefits. Then there's always this, there's a lack of standardized methodologies or frameworks and best practices for sustainable software architecture. So this makes it more challenging for the organization also to establish consistent guidelines and benchmarks for designing environmental conscious software systems. So engaging with the industry initiatives, sharing your best practices with the wider community helps to address this. So we can develop, our own internal standards and guidelines for sustainable software architecture based on the industry's best practices and lessons learned. And this is also often a limited awareness and expertise within the software development community about the sustainable software architecture and practices. So we need to invest, the right investment in the training and education initiatives, be it, to build the expertise in the sustainable software architecture is very essential. So providing developers with the knowledge and tools, they need to kind of integrate their sustainability considerations into their design and development process can help drive the adoption and implementation of sustainable practices. Legacy systems and technical depths pose challenges to implement sustainable software practices, basically retrofitting these existing systems to meet the sustainability goals. can be difficult and costly. So prioritizing sustainability in the software modernization efforts and adopting incremental approaches, to refactoring legacy systems can help address this challenge. So the organizations can prioritize sustainability focused refactoring and invest in technical debt reduction strategies to gradually improve the environmental performance of the legacy systems. And then we have the regulatory and compliance requirements. So the compliance with the regulatory requirements and the industry standards related to sustainability can be complex and can be resource intensive. So staying informed about the relevant regulations and standards and how we proactively integrate it with the sustainability can ensure the compliance. So again, coming that there are various sustainability frameworks and certification programs that can provide some guidance and validation of the sustainable software architecture practices. So by addressing these challenges and considerations, then organizations can overcome the barriers to implement architecture and design systems that minimize the environmental impact while meeting the business objectives and user needs. Moving to the next slide. So one important thing is just the previous slide, Kitty. Yes, that's, thank you. So one important thing is selecting and scaling the right sustainable IT use case, right? So the research shows that the sustainable IT use cases that organizations do manage to get to scale are not necessarily the ones that will deliver the highest carbon reduction. So, for example, switching to a green cloud architecture and framework is given, the organizations that have been able to scale the solution organization wide, with this much amount of savings, but they've not even either heard of it or have not even implemented it. So the most adopted use case is moving to enterprise cloud applications. The adoption of cloud computing, could prevent, the emission. However, shifting to the cloud will not be sufficient in itself if applications are shifted as is without redesigning from a sustainability practice. So such as a lift and shift migration approach can negate some of the sustainability benefits of moving on-premise applications to the cloud, as the original application architecture may be resource inefficient or carbon intensive. So organizations should therefore redesign their applications before migrating to the cloud. So in addition, the adoption of the green cloud architecture is equally important, as it reduces the power consumption or improves the resource utilization in the cloud computing environment. So moving to the next slide. So just want to reiterate that sustainability need to ensure that it's a key pillar of the software architecture. Multiple aspects of the software architecture can improve an organization's sustainable IT capability. Taking a sustainability perspective with software architecture is as important as focusing on performance and cost issues. So research also shows that most organizations that have been able to scale these approaches not only achieve a carbon reduction, but also additional cost benefits. So bringing sustainability into software architecture means understanding the environment consequences of the software deployment and setting clear solution related principles on sustainability. So also ensures the software architecture includes a sustainability perspective and making deployment decisions based on the carbon cost of the infrastructure, creating a balance between the value of money, be it the agility, compliance, and sustainability. So once the software architecture is available, the design of specific software modules within the architecture must be viewed from a sustainability perspective. So for instance, helping developers understand the carbon cost of their software models and using green coding to produce algorithms that have minimal energy consumption. So I've based on the sustainable software architecture. It's really a critical aspect of our environmentally conscious software development. And here are some of the actionable insights for organizations looking to embrace the sustainable software architecture. Um, invest in education training, foster basically a culture of sustainability within the organization by providing education and training on sustainable software development practices, equip the developers and architects and stakeholders with the knowledge and tools that they need to integrate the sustainability considerations into their work. Incorporate the sustainability metrics into the key performance indicators and decision-making processes. Track and monitor these energy consumption, or be it the resource usage and environmental impact throughout the software development lifecycle to measure a progress towards the goals. Engage with the industry initiatives, collaborate with the the waste organization, share best practices with the wider community, and leverage the knowledge sharing platforms to learn from others and drive collective action towards the sustainability. Prioritize the sustainable design principles such as modularity, reusability, and energy efficiency in software architecture decisions. Design systems that minimize the waste, maximize efficiency, and promote the environmental responsibility from the emerging technologies and trends such as be it the cloud computing, the edge computing, that offer opportunities for enhancing your sustainability, and leverage these technologies to optimize the resource usage or the energy efficiency, and finally adopt a mindset of continuous improvement and iteration in the sustainable software architecture. Regularly evaluate and optimize the systems for sustainability, incorporating the feedback, lessons learned, and any new innovations into the future development efforts. So by taking these actionable insights into consideration, organizations can embrace sustainable software architecture practices and contribute to a more environmental sustainable future while driving innovation and delivering value to their stakeholders. So, and moving on to finally, we'd like to end this this discussion with with one very nice quote that I came across, that the best software architects understand that true sustainability is achieved when technology serves humanity and the planet in harmony. So thank you. I'm open for a discussion. I'm sure, it's a new trend that's there, and you also will have your perspective or your point of views, to share it with this group.
If anyone has any question, please put in chat. Okay. Sahita? Go ahead.
Is anyone having any doubts? Ma'am, I think from one of the candidate we got the question.
I have a question if I can ask.
Yeah.
Yes,
Yeah,
please.
yes, please. Yes, please.
First of all, thanks for this insight. It's really interesting topic. And when it comes to sustainability, I see that the architecture perspective is not taken seriously, as you rightly said. And the point is there are a lot of disparate information scattered, right? I'm looking for any specific specialized industrial framework or architecture group which focuses on the consolidation in this stage, but we can all follow same, because if you say multiple frameworks comes, then again the sustainability part of this architecture misses out. So is there any standard framework across industry or verticals or globally which is being taken up in this space?
Yeah, there's no standard thing which has come up because it's still kind of evolving, and each of them, within the organization, we kind of evolve it. But there are some set of guidelines that is being think. There's something called sustainability software, kind of framework, SSEF, and there are also some guidelines to say how you go about doing the assessments throughout your life cycle and do it. But there's no thing as a standard thing that okay, we follow it, something like an ISO or so, right? But each organization can leverage some of the framework, and then we kind of customize it for our specific needs.
Okay, and thanks for that. And add on that in this structural software architecture, is it focuses mostly E part of that ESG or other social comes in that software architecture or governance as well?
Yeah, the governance is there, E is there. Mainly what we're concentrating here is how I go about doing in through the life development cycle, right? Where in every phase, how I bring about, the sustainability goals, to be ensured part of it.
Okay, thank you.
There are a
Hello.
few more questions you can see in the chat.
Yeah. My name uh, is Vatsal Shah, and thank you, Madam, for giving this wonderful session. This is quite helpful. Okay, as part, I want to know what are the different patterns that you have implemented or used. The one that implemented event oriented pattern, right? Is because of the saga pattern, right? Uh, orchestration and uh, and the choreography pattern, right? So can you please share some knowledge patterns that are being used that can be used to achieve this?
So some of the ones which is common thing is on the process orchestration, right? Now, when it comes to the API, the development, um, instead of making multiple kind of a server request all the way up, to see how you can orchestrate it and share only what is needed, to the front end part of it, right? That kind of orchestration is very much needed when we're making multiple API calls. It's just one of the examples, which I'm kind of, suggesting where this way it kind of reduces your network because you don't want to make so many multiple calls and that kind of thing you can bring it within your orchestration layer itself by implementing maybe within the caching or on the lazy loading as part of it because sometimes we have seen some real bad design where even though for a particular screen I might need only this many number of fields but then still we make an overall call to get the entire data which is there within my API more like a system API, right? And that's where we bring that kind of some kind of optimization in the process layer when we're orchestrating what is has to be given to the front end. It's just one example I'm just saying.
Okay, thank you so much.
Anybody would like to share their views or anything where you're using it elsewhere in any of your
Yeah,
areas?
so I can share my views. We are building a sustainability data platform.
Okay.
And the challenges we are facing when trying to get data from multiple places, right? To build a platform need to capture the sustainability data. Some of the systems or the data availability, the bigger challenge in the space of building an ecosystem where we can get sustainable consumption data or CO2 emission data from multiple systems. For example, if you go to cloud providers, you will not get data at every resource level, what each resource consumption from my carbon perspective or services perspective. You can get totally consumption carbon, but you will not get like what like for S3 service, how much I'm emitting for one of my EC2 machines, how much I'm getting the data emitted, right? So if that is not available when we try to design a sustainable software architecture, then in case of planning my infrastructure, because which is the biggest part of our software life cycle, which consumes the compute is basically the biggest part of sustainability when we consider the sustainable software architecture. Another aspects which is the data consolidation, especially if you go to system like SAP, ERP, for certain model you'll find the data, but certain space you don't have data. Data from a transportation in consumption, so software delivery, or a uses or data clutter, basically if you see those kind of data also they're difficult to get. Like for example, if you're doing a writing algorithm for image analysis, you may get a lot of clutter, like your camera will give you 60 or 70 odd frames per second. But you may not need those 60, 70 frames odd per second because human movement is very limited. Hardly a second the human moves, right? So those can be reduced. But those kinds of consideration is very difficult to find. And the data to build your sustainability platform and consolidation, the bigger challenge we faced it. So if you go, and also when you go to carbon calculation Indian perspective in the market, there's so many companies that are doing their own proprietary way, right? Like EPA standard they follow, but EPA seems like a black box for us. How will I know what calculation going on, which attribute going on the EPA calculation for carbon when we do a sustainability KPI creation for CSRD reporting or your other reporting agencies, right? So those are the challenges we are observed when it comes to the real perspective of implementing a solution on sustainability. So that's my thought process and challenges we faced.
That's true, because even each of the platform, as you rightly said, I mean, not everything is being, considered with respect to on the what are the parameters that they're using. It's still an evolving, still being evolved. Each of the platform are claiming that yes, they are already including their sustainability parameters to capture it. But yes, I agree to that it is still kind of being evolved only as part of it.
And another challenge we face is like how you distinguish between greenwashing and actual reporting. So then a specific standard where say people are doing greenwashing and then claiming by leveraging some of the other stuff and then saying that we are doing, like for example, Yulu and Zomato collaboration. I don't know to name, but some sort of things like that is coming like greenwashing space. So what is the thought on the greenwashing space, how we can avoid that and track basically the greenwashing perspective?
Greenwashing thing, I'm also not kind of very familiar with that particular aspect, part of it. But at least from the developer's perspective, at least what we are trying to do within our thing is how we can go out and inculcate that, right? Consciously kind of people do the development consciously keeping it impact on how to be it on the energy efficiency or on the resource efficiency, with respect to that part of it is where we are kind of really concentrating on.
Correct. Thanks.
And then second to that thought that if the cloud providers like AWS and Azure publish their kind of KPIs for each of the cloud services with the PaaS services, that this is a percentage of sustainable numbers, then it would help for the consumers like us, the architects and developers, to pick and choose which service from which cloud provider is best for the sustainable architecture to be included, a component to be included in our architecture. Probably just a loud thought, but probably it might help if Cloud, Azure, and AWS can publish their sustainable reports and break it down to service levels. It will help.
Yeah.
Right. So we have
That's
something
true.
on AWS we tried, but the problem is it's giving at the complete level, not at the breakdown level. The AWS gives you carbon dashboard for your consumption, but not a detailed level, which I was referring to. You're right.
So just
another
picking up
question.
on that thread, what Anupam and Deepak said, we have some of the solutions in-house that can look at the proper utilization of the cloud services and the underlying resources. While many are moving towards serverless, this becomes a black box to us because it's more provided as a service. So we don't know what is exactly happening in the data center, right? So we try to develop a solution which can actually tap in and figure out within a service what exactly happens, and it's very difficult to distinguish for my service how much it happens because these are all virtualized, right? So if you take, for example, CPU, or if you take disks, right? AWS data center hosts it in this way, and Azure and GCP, right? Such a way that it is very difficult to find out for a particular project, for a particular workload, how much is the carbon footprint, right? So that is where we are struggling to kind of call out, okay, how can I determine the carbon footprint for a specific work for a specific client, right? That's the challenge, but we read the annual report that these companies publish, and we also take advantage of the carbon tool that they publish.
Yeah, thanks, Raul. The second question, probably it is a kind of a thought sharing with you is now that the latest trend, the generative AI has come up, which requires too much of computing demands and memory demands. What guidelines do you have for a budding technology like that, where we are forced to include that in our portfolio? So, what guidelines do you have from the sustainability, apart from what you have already said? Manjula, is my question clear?
I think she's stuck
Yes,
in
I'm
mute.
all. Sorry, Anupam, was my question clear? Was I'm
Yeah, it's
audible?
very clear. So for you rightly said, for example, a model like ChatGPT training takes 30 household energy for a whole year, right? That much energy guzzling these generative AI models are there. So definitely
Yeah.
sustainable. It's a bigger pain for the generative AI, the big impact putting on sustainability, like 2 days nuclear power energy taken to train a model, right? And the model size is
True.
going like billions and billions of parameters, right? 6 trillion, 7 billion, Bloom's 300 billion parameters. It is crossing trillions. So I see a trend coming to the market, like they're trying to do a reduction in not big is not the best, something like strategies coming in the market. So what they're trying to split the model in smaller size and trying to rationalize the model parameter size and see if there's a trade-off between a slightly higher accuracy plus your model and sustainable model consumption for energy perspective. So that trade-off being discussed on, that's from my study. And the people are preferring smaller model size, the slight tweaking and fine tuning with lesser energy consumption instead of going a bigger size models like Bloom, because nowadays you see every model is being deployed in a mobile phones or your laptops or your or news, wherever you go, any device, the AI is running. And every query to your chat GPT impacts a lot of network traffic, going to model inferencing, right? All this. That definitely impacts a lot. But yeah, there is a concern going on around the world and they're trying to rationalize that. How can we make generative AI more smaller model much better with more data, lesser data requirement and fine tuning so that the impact to sustainability environment will be lesser. That's my study.
Yeah, true. Manjula, do you have any
Sorry,
comment?
Deepak. Yeah, sorry. So, just to add, no, to what Anupam was also saying, right? I think choosing the right existing model is also good. I mean, there's one view saying should we overtrain the AI model so much and make it so very heavy, right? Or keep only the required, use only the data that is required to meet the the user use case needs or so. So I think it definitely having the right size kind of models or how you go about conserving the energy, right? Using those kind of computational methods, to derive that particular data from the LLM, right? How we go about conserving it. I think that's just my view on that.
Thanks.
Everything for the, I mean, the trend is like sustainability and Gen AI. That's the two new buzzwords.
Yeah, it's like fourth revolution they're calling.
Yeah.
Everybody's looking for Gen AI.
Yeah, Sahiti.
Hi, Chandra Garu. Sahita just moved for the other meeting. So,
I'm there. Thank you,
you're there.
Manjula ma'am, for the enlightening your seminar you hosted. So, and your expertise and insights very inspiring for us. We are looking for more of these seminars in the future.
Thank you. Thank you so much. Thanks a lot.
Thank you.
Sir,
Thank
and
you.
It was
thank
a
you,
learning for
Josh.
me also. Yeah. Thank you.
Great session.
Thank
Thanks a
you.
lot, everyone. Thank you.
Thank you. Bye.
Bye.
Thank you. Bye-bye. Sahita, you may want to propose vote of thanks and complete. Sahita?
Sir,
Yeah, propose vote of thanks and
thank you all. Thank you so much. Thank you, ma'am. Thanks for joining.
Thank you. Thanks a lot for this
Thank you all.
invitation. Thanks a lot. Thank you. Bye.
it's
Thank
really
you.
a very useful session, Manjula madam. Thank you. We are privileged to have you as a speaker today. And thank you,
Thank
Kirti.
you.
Your continuous support is Really, highly appreciable. Okay.
Thank you, Chandra.
Yeah. Thank you, Rajshri Madam. Thanks
Thank
for ISTS. Okay. Yeah. Saida, you may start the session.
Sure.
Okay. Thank